Let's go down. Our heads down. Okay, today we are looking at image formation. Image formation without mirrors. In physics, there are types of image formation. First of all, we are going to look at when the object is at a point beyond C. A point beyond C. When the object is at beyond C, I need you people kuja hapa mbele na touch. Utachata je. Bado na ndepeni. Kuja hapa mbele nipige touch. Okay, we are talking about an object which is beyond C. The object is beyond C. On our principal axis, we have 3 points. One is the P, we have F, and we have C. This is our reflecting surface of a concave mirror. This is F, and this is the focal plane. The focal plane passes through the principal focus. Who can give me the distance PC? What's the distance PC? Yeah, what's the distance PC? Two twice. That's what's the distance to P? The distance PC is twice PF. Right? I said the distance from P to C is twice the distance from P. That means if the distance from C to F is 1, the distance from F to P is 1. So the first image we are looking at the object is beyond C. Then this is our C. What is C? C is the center of curvature. The center of curvature we say is the radius, is the center of the sphere from which the reflecting surface was cut from. This is our sphere, and we cut this side. So we have this to the center. This is the side yenye tumekata, si ndio? This is the reflecting surface, and this is C, meaning is the center from the sphere of which the mirror was part of. So that's the center of curvature. What is F? What's F? F is the principal focus. What is P? P is the principal axis. Then we have this one. X, Y. The width of the mirror. How do you call that? The aperture. Aperture is the width of the mirror X. Now we are not looking about that. That's what we learned in the previous class. We are looking at when the object is beyond C. We talked about the types of rays. The 4 rays we talked about. The first one was a ray passing through C. Why is it reflected through? If a ray is passing through C, it's reflected back through C. The second ray we talked about is a ray at an angle. If you know the answer, you raise your hand. Don't need for us to answer. The next one was a ray at an angle. The third one, who can say anything about the ray at an angle? Okay, what he's saying that when you have a ray at an angle, it simply means that we have an incident ray and then we have a reflected. Between the two rays we have the normal light, and this is the incident angle which is dirty, and this is the incident ray. The incident ray is the surface of the reflecting surface at an angle of 30 degrees. It's reflected back at the same 30 degrees. So the incident angle and the reflected angle are the same. That's what we talked about. We are not talking about image formation. The fourth one is the fourth one. The type of thing. Very parallel and close to the principal axis. These are principal axis and the ray parallel in and the parallel to the principal axis. They don't preserve. So in this diagram we want to draw the types of ray I've talked about. The first ray from the head of the dog in the diagram through C. Where is it reflected through? Back at C. If it's through C, it's reflecting back through C. The second ray is parallel across the principal axis. Where is it reflected at? I don't want chorus answers. No, that's a trial. Where is it reflected at? The ray is reflected back through F. That's the first diagram. This is the image. Where is the image formed? This is the object, this is the image. This ray is reflected and this is where they meet. So this is where we draw our object. So these are objects. Where are we forming the object? The object is being formed between C and F. That's the first one. The second one, what you guys say about the size of the image? The size of the image is not virtual. That's a term. The size of the image, yeah, is this the same size as this one? This is my object, this is the image. Ukiangalia hii na hii zinatoshana. But that child, the age umesema but it's not correct. The size of the image is inverted. Okay. The size of the image is inverted. Those are two different points. What one says? Okay, the image is smaller than the object. The size is smaller than the object. So we have this. These are object and this is the image. The image is very small. It's shrink. Kamekuwa kadogo. Compared to this one, it's the object. The next one we are talking about is the image real or virtual? Real. The image is real. Why is it real? Who can say why the image is real? Okay, the image is real because it's formed by real rays. The image is real. The image is formed between C and F. The image is smaller than the object. There is one characteristic remaining and it's observable. Where is the edge of this object? The shape of how does the object differ from the image? Now the image is inverted. So we have looked at the object beyond C. That was the first object beyond C. The next one is object. We have looked at the image formation object beyond C. This is object beyond C. It's formed between C and F. If they ask you the characteristics, we say the first one formed between C and F. The second one is formed between. The second one is the size of the image. The object is big, the image is small. The third one we are talking about it's a real object. Now real rays form real image. An object and an image both are real. See look, these are real rays. And the last one we are talking about inversion. The object is upright, the image is inverted. Those are the characteristics, 4 characteristics. Now we are looking at the second type of image formation. We are going to look at when the object is at C. When the object is at now these are P and C. Now these are objects at C. The object is at C. Which ray are we using here? We said we have four types of rays. Which one are we using? One, we're using the ray parallel and close to the principal axis. That's our first ray. Indio. Why is it reflected through? No chorus answers. We follow you. Back to C. Being reflected this way. No. Yeah, how is it reflected? You said back to C. This is back to C. From here to here, that's back to C. That's correct. We have this one reflected back through. It's passing through F. This is the trade, and this ray is parallel across the principal axis, and it's reflected through F. See that? Yes. The next ray we are using is a ray through F. Where is it reflected through? But it's okay. The second ray is through F. How do you reflect this ray? By parallel and close the principal axis. It's reflected back. Senior? Yes. This is the ray and it's reflected back to this, where they meet. So, they meet at a point C. If drawn to scale, this is our reflected ray. This is our first ray. Through F, it's reflected back, parallel close to the principal axis, and these are object formed. Characteristics of this object, you can see. One, where is it formed? First characteristics is formed at, our image is formed at a point C. The next one, is it inverted or upright? The image is inverted, formed by real rays. How do you say, is it virtual or real? What are you talking? What are you talking about? Yeah? Okay. Is it real or virtual? Okay, you mnajua wote mseme wote. The image is. What about the size of the image? They are the same. The object and the image are the same size. Those are the four characteristics. One, inverted. Two, it's real. And three, forms as C. The last one, same size as the object. Any question on the two types of image formation? Before I look at the third one, do you have a question? Or I ask a question? Okay, let me ask a question. When an array is parallel and close to the principal axis, where is it reflected back through? This is the principal axis, this is the reflecting surface. We have arrays parallel and close to the principal axis. This is K and this is F and this is C. Where is the ray being reflected through? Through? Yeah, it's reflected through F. Now let's look at the other image. The other type of image formation we are looking at an image formed between C and F. Are you together? There's an image formed between C and F. We draw our principal axis, the reflecting surface, remember the type of mirror we're using is concave. And this is the pole, this is the principal focus, and this is the center of curvature. Now, the object is between the center of curvature and the principal focus. It's in between here. Cinder, this is our object. Which first ray are we using? Who can try? The type of ray we are using? Which ray are we using? That's correct. Can you clap for Bio? Yeah. The ray is parallel and close to the principal. Parallel and close the principal axis. Where is it reflected through? The image is reflected. The rays are reflected through F. The next one, we have a ray through F. How is it reflected? Yeah? It's reflected back, close and parallel to the principal. Wait, it's not reflected through C. It's a ray from the object through F. It's through F. It's not through C. The only ray that is reflected through C is the ray passing through C. So, this one is a ray passing through F and it's reflected back through. The ray is through F, meaning it's reflected parallel across the principal axis. It's the same as the ray parallel across the principal axis is reflected through F. So if a ray is passing through F, it's reflected parallel across the principal. So this is our object. The object is formed here. Who can see any characteristics of that object? Is it the object real or virtual? The object is real. Another characteristics of the object is formed beyond C. Is it inverted or upright? Is it inverted or upright? Inverted or upright? It's inverted. It's real because it's formed by real images. It's formed by real rays. It's a real. It's formed beyond C and it's inverted. There's only one thing you have not talked about: the size of this object. The size of the object is small. The size of the image is. So that's why we say the image is magnified. Object at F. The first ray is parallel across the principal axis. That is normal clamp anajua, sindo. That's the object. Where is it reflected through? It's reflected through F. Where are we reflecting the other image from? The other ray. Yeah? How many types of rays do we have? 4. The first one was through C. The second one through F. The third one parallel across the principal axis. And the last one? Say the answer. I don't need for us to. So the ray pattern. So now we are using the ray through C. So on this object we are using a ray through C. So we talked about 4. Through C. Senior. Array reflected through C. How is it reflected back? Array passing through C. How is it reflected back? How is it reflected back? Yeah? That's not right. Yeah, if array passes through C, it's reflected back through. Now, if this one is parallel across the principal axis, is reflected through F. This line will never meet. So that's why we say the image is at infinity. So the image is formed at infinity because the rays will never, when the object is at F,